So today's video will be on graphing data. Our learning goal for today is that by the end of the lesson you'll be able to create and interpret various graphs, including dot plots, column graphs, stem and leaf plots, pie charts, and divided bar graphs. Okay, so one of our key ideas today is that data can be numerical or categorical. Okay, so that means it can be a number. So for instance, if you're looking at people's shoe sizes, you'd have a number, 5, 6, 7, 8, whatever. That's a numerical data. Or it could be categorical. So it could be, what pet do you have? Dog, cat, fish, guinea pig. That would be categories of data. So numerical data can either be discrete, so it can only be a particular numerical value. So for instance, number of people. So it's only going to be whole numbers. You can only have one person, 2 people, 3 people. You can't have half a person or 0.5 of a person. It has to be, it's a discrete data. It has to be a particular number. Or you can have continuous data, which can be any numerical value in a range. So for instance, time, that could be any value, it's continuous, or we could have height or something like that. It's continuous data. So categorical data is non-numerical data that can be grouped into categories, as we've already said, like pet type or favorite color or favorite food or anything like that. And we can represent this data as graphs or in tables. And in today's video, we're going to look at a few of those different graphs. So one of those graphs is a dot plot. So I've got a dot plot there, which is the number of books read per month. So a dot plot can be used to display data, and every single dot represents one data point. So for instance, how many people read 8 books a month? So we'll go to the 8 column and we'll count the number of dots. So there's 2 dots there, so it means 2 people read 8 books in a month. So 2 people are very lucky enough to have time to read 8 books. How many people were surveyed? Okay, so this is going to take us a while. We're going to count every single one of those dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So there were 50 people who we surveyed for this. So each dot is a different person. There are 50 dots total, which means 50 people total. So find the range. So the highest number, we take the lowest. That will give us the range. So our highest number is 9, so that 9 books were read, and our lowest is 0. So our range, 9 take 0 is 9. So our range would be 9. Our median and our mode. Okay, so remember, our median is the middle point. So the 25th point would give us our median then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So if you counted that as well as I did. So 4 books read is our median. So our 25th person surveyed, when we put it in order, was 4. So 4 books. And the mode is the most common, which is easy to see on the stem and leaf, which is just which has the highest amount there. And this one's bimodal, because we've actually got 2, and that's 7 and 9 books. They're the most common. So are there any outliers in this data? Any points that are really high or really low compared to the others? There's actually not. It all seems pretty evenly spread with a range between 0 and 9 books being read a month. If you're reading 0 books a month, you need to start reading more books. So we'd say no, there's no outliers here. If we had, another point here that said, like 56, and a person read 56 books, you'd be like, whoa, outlier, we'd get rid of that. But everything's within a kind of normal range there. Okay, column graphs, sorry. So column graphs need to have a number of features. So they should have a title describing what the graph shows. So in maths and science, our titles are a little bit different to what they are in English. So our titles are kind of like spoilers. They will tell you exactly what you're going to look at. They're not giving you any, cryptic hints or making you trying to read further. They're going to tell you exactly what it is. So for instance, the population of Australian states and territories, 2006. So that doesn't leave anything to the imagination. It tells you exactly what that graph is about. That graph shows the population of Australian states and territories in 2006. So it also has a label on each axis and units where appropriate. So down the bottom, it's categorical data, so there's no units needed, and it's states. And then on our y-axis, we have population, and that does need a unit, so it's per 10,000. And then we have an even scale for any numerical axes. So you can see here on our y-axis, we're going up in hundreds, which is hundreds of thousands. So 0, 100, 200, 3, 4, 5, 6, 7, 8. So it's going up evenly there. And category labels for any non-numericals. So we've got labels on each of these points, so we know exactly which state or territory we are looking at. So there's our column graph. So we can quickly see there, Northern Territory had our lowest population, and New South Wales had our highest population. There we go. Okay, so column graphs, we're going to do a few questions about a column graph. So the column graph down there, obviously, we can see that there's an issue. It doesn't have a title, so it should have had a title. But the column graph represents the annual income of 5 people. So what is Aruvin's annual income? So we're going to find Aruvin on our x-axis, which also should have had a title. This is him here, or her, Aruvin, and we'll look at their annual income. So their annual income, we can quickly see, is $60,000. There we go. So what is the difference between Jamie's income and Ashdiv's? Okay, so the difference between Jamie and Ashdiv. So Jamie's income is looking like it's about $90,000. So $90,000. And Ashdiv's is $40,000. So we're going to do $90,000 take $40,000 to find out the difference. And their difference there is going to be $50,000. So that's the difference between their incomes. So $50,000. Poor Ashdiv there. And who earns the most? Well, we can easily look there. That's Stefan. Lucky Stefan. He's earning $100,000 a year. There. So we can easily interpret data when it's presented in a nice clear graph. Okay, pie charts. Pie charts can be used to show proportions of a whole. So the arc length, which is, this circle bit here, is proportional to the quantity that represents. So the whole thing, the whole circle is 100%, and then we're kind of dividing it up. So you can see here, the one that I drew, which was action, so people's favorite types of movies. This represents about a quarter of that circle, and it actually represents a quarter of the data. And then you can see over here, drama only taking up a very small percent. It takes up 5% of the circle, and it represents 5% of the data. So the size of the wedge represents the percentage of the whole. So if we were to add up all our values, so the 25% that like action, the 20% that like comedy, 20% who like sci-fi, 5% that like drama, and 30% that like romance, if we were to add all of those together, we would get 100% because the whole amount is the whole circle. Okay, so we're going to do some questions on a pie chart. So our owner graphs the amount of money spent per year on car-related expenses. So what is the largest expense per year? So even though we don't know the dollar values, we can just look at this pie chart. Which one takes up the most of the circle? Petrol. So petrol takes up most of it. Okay, what percentage of the car's expenses is devoted to maintenance? So we'll find maintenance. This is the yellow one there. And you can see that maintenance actually takes up a quarter. So a quarter of the a quarter of the expenses are maintenance. What's the percentage? So 25%, because this wedge here is 25% of the wedge, so we know it takes up 25% of his expenses or her expenses. So if the car owner spends $3,000 per year on petrol, what is the total amount spent on the car each year? Okay, so the question tells us $3,000 on petrol. If we look at our pie chart, petrol takes up exactly half of the circle. So half the amount of money goes on petrol. So if half is equal to $3,000, obviously the whole would be $6,000. So the amount they would spend would be $6,000 on their car per year. Okay, so stem and leaf plots. So stem and leaf plots are the next type of data we're going to look at, and they're used to display numerical data only. So we can't really show categories using these like we could with our other data types. It's only numerical data here. So each value is split into a stem. So for instance, this would be our stem, and our stem is the first digit or the first digits, depending on how long our numbers are, and the leaf, which is the last digit. So our question is, state the numbers represented in this stem and leaf plot. So for the first one, our stem, which is our first digit, is 0, and our leaf is 2. So that would actually just be representing the number 2. Our second one, our first digit is 5, and our leaf is 1, which is our last digit, so it's just 51. Our next one, the first two digits are 1 and 3, and then the last digit is 7, so it's 137. So that's kind of how we interpret these plots. Okay, so represent the following data as a stem and leaf plot. So sort the values first and then calculate the median and the mode. So we're going to sort the values from lowest to highest just because I think that's easiest. So I've got 2, I've got 2 again. What have we got next? 14 looks like it's the next lowest. Yep, 14. And we've got 20s. No, 15. 14, 15, 20. Oh, I should put commas here. 15, 20. What's next? We've got 20. Oh, I forgot 10. Let's add in 10. Ooh, 10. What have we got now? 25 is the next? Nope, 24. 24, then 25. And then we've got 33 by the looks of it. Let's do another comma. And 37. Comma. And we've got 3 lots of 41. 41, 41, 41, and lucky last is 46. Okay, so we've sorted our data, and we'll need to represent as a stem and leaf plot. So we're going to write out our stem and then our leaf. Okay, so our stem is the first values. So 0 for all those numbers under 10, then we've got 1, 2, 3, and 4. And our leaf, this is when we fill in our values. So we'd have 2 and then 2 because we've got 2 values of 2. For 10, it's just a 0, and then we got 14, and we had 15, and then we had 20, 24, 25. For 30, we had 33, 37, and then for 40, we had 41, 41, 41, and 46. So if you see, that's how we'd represent multiple values there. So if you've got multiple values, you can put a comma between them just to make it clear, or you could space them out with a spare space between them so it's obvious that they're separate numbers there. Doesn't really matter because the leaf is always the last value, so we know there's only 1 there. So the 2, for instance, with this first one where it says 2 and then 2, it's obviously just a 2 because it's always the last value, so it can't be 22, otherwise it would be, over in the stem part. Okay, so we've done our stem and leaf plot there. So calculate the median and the mode. So I'm going to do mode first because that's the easiest. Our mode is our most common, and we can see that's 41. So our median is our middle value. So how many values do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's an even number of values. So again, we'll have to work out can't think of the word, the average of the middle ones. So 1, 2, 3, 4, 5, 6, 7, 24. So our median, we have 24 plus 25, which we're going to divide by 2. Obviously, I'm sure a lot of you could do this in your head. 24 plus 25 is going to be 49. Divided by 2 is 24.5. So our median is 24.5. There we go. So that's our stem and leaf plot. We've calculated our mode, which is our most frequent, and our median. We had 2 in the middle, so we had to do our mean of our 2 values. Finally, I thought of the word mean. Okay. Okay, so another type of stem and leaf plot is a back-to-back stem and leaf plot. So these are used to compare 2 sets of data. So in this case, we put the stem in the middle. So this would be our stem here. And we'll put leaves on either side. So that would be one leaf, and this would be the other leaf. So from here, we can kind of compare things. So for instance, this one is the scores of 2 teams for the last 20 games. So you can see the scores here. So team A scored 0, that's not good. And then they scored 4 points. So this would be 0, 4. Their other scores would be 18, 12, 11, and 10, 29, 21, 33, and 32. And that would be all they scored. That's unlucky. On this side, we had 22. Team B's killing it, 27, 39, 43, 45, 46, 46, 50, 51, and 53. So you can see the scores that they had. So symmetrical data will produce a graph which is symmetrical about the center, while skewed data will produce a graph which indicates data bunched to one side. So obviously both of these teams had skewed data, because our center would be, around our 2 and our 3 mark here. But we can see for team A, theirs is skewed around that end, and team B, theirs is kind of skewed around the other end. So we have skewed data here. And that's all we have for today's video. So hopefully you've learned a little bit, or refreshed at least, on all the different graph types. I know it's a bit of a longer video, but we have covered a lot here. As usual, any questions at all, come and see me in class.